All right, guys, so today we're going to talk about a couple little things regarding climate change. And you can tell from what you've seen in the PowerPoint already that I'm trying to give you all of the information that we have kind of summarized so that you can understand that there's more than one thing that plays a role in climate change. It's not just humans' role that is driving climate change. It's not just natural causes that are driving climate change. It's a combination of the two. And if anything, according to the information that is available, that isn't necessarily made very available to the public, but scientific research shows that there's very much happening naturally that is leading to climate change, or can be cited as a result of climate change. We have had increased solar activity. The hotter the sun, the hotter the celestial atmosphere, the hotter our atmosphere. Okay, we have had more volcanic eruptions, which is typically the result of subduction in the past few decades than we've had in much of recorded history. And both of those things lead to a significant amount of greenhouse gases going into the atmosphere. And we are also playing a role, not just by burning fossil fuels, but by simply being alive. Okay. People who are advocates of an anthropogenic influence of climate change. And when I say anthropogenic, I'm talking about the human induced. Okay, so the human component to climate change, the anthropogenic influence. Okay, people who side with this rationale cite the Industrial Revolution of 1837 as the onset of global warming because of all the burning of fossil fuels that took place then. Something that people don't typically mention is how population growth is playing a role in climate change. Think about this. What do you breathe out when you breathe out? What comes out of you? Carbon dioxide. What else comes out of you when you breathe out? Water vapor. What else does your body release when you're gassy? Methane. Water vapor is the #1 most effective greenhouse gas, and you can see that on the other PowerPoint. This PowerPoint here from the book totally ignores water vapor because there's nothing that we can do about water vapor. Okay, we don't really control the amount of humidity in the atmosphere. We play a role in affecting it and influencing it, but you're not going to take water vapor out of the atmosphere. The world's already dry enough as it is. We need more water, not less. So that's not something that environmental science really addresses. They more or less disregard it. But water vapor is the #1 most effective greenhouse gas by 72% of any other gas, 3 times more effective in the role it plays on climate forcing than any other greenhouse gas. And that's something that humans emit just by breathing. That's something that all mammals emit just by breathing. Okay, we also emit carbon dioxide, the gas that is cited as the major player in global warming, and we also emit methane. These are the top 3 greenhouse gases that every single human being emits on a daily basis. Okay, think about that. In 1837, there was not quite 1 billion people on the planet. Today, we have had rampant population growth, and we have over 7 billion people on the planet. We have over 7 times the amount of living, breathing, farting individuals on this planet, adding to the top 3 greenhouse gases in the atmosphere. 7 times the amount. Think about something else. What do we eat? Majority of us eat a lot of livestock, okay? And that livestock emits the same greenhouse gases. So the population growth of livestock on this planet is directly correlated to the population growth of human beings. Let me ask you another question. How many of you have pets? How many of you have cats, dogs, hamsters, gerbils, ferrets, who knows, any of them, all of them emit the top 3 greenhouse gases. So not only has the population of humans increased, the population of livestock has increased, and the population of domesticated animals has increased. And every single one of those things emits the top 3 greenhouse gases. Okay? So aside from our dependency and our usage of fossil fuels, we have added to the amount of greenhouse gases in the atmosphere simply by being alive on this planet and essentially having an overpopulated planet. Okay, so let's take a look. Let's step away from whose fault is it and take a look at what's going to happen. Okay, what we need to pay attention to. Sea levels are going to rise, and agriculture is going to change and most likely become limited. Okay, and this is due to climate band shifting and countries not being prepared for it. Okay, so mitigation I've gone ahead and crossed out because limiting the number of greenhouse gas emissions isn't going to do anything in our immediate future. It takes about 1,000 years for the atmosphere to equilibrate with the earth, or excuse me, with the ocean. Okay, and so the damage that has been done, it's going to continue to play a role for the next millennia. Okay, even if we were to stop all greenhouse gas emissions today, it would take a minimum of 500 years to see the benefits of that. Okay, climatically speaking. And so we need to focus less on mitigation and more on adaptation, learning to live with environmental changes. Okay, should we reduce our greenhouse gas emissions? Absolutely, because that's what pollutes our air. Okay, but we shouldn't do it because of the misconception that it's going to stop climate change from happening. You can't stop climate change from happening, and you've learned this from the Milankovitch cycles. The long-term driver of climate change is how the Earth orbits around the sun. It has everything to do with orbital variations of our Earth in its trek around the sun, and less to do with what's going on the Earth's surface. It also is intrinsically tied to solar activity. Okay, so in the long term, on the millennia or greater scale, it's more about how the Earth travels around the sun, less about what's going on the surface. In the 500 to couple hundred year scale, it's more about what's going on the Earth's surface. Okay, so you can't stop these trends. The trends that we're having with climate change right now would be happening, maybe not on as great of a scale, maybe not as fast of a rate, but this warming would still be taking place. And it's believed that we are cresting, or that we're approaching what's known as a tipping point. And so our next immediate future is a cooling phase, because that's how climate works. It gets hot and then it gets cold. So instead of trying to prevent the Earth from getting warm, we should learn how to prepare for a warmer Earth. And a lot of those things involve getting ready to shift the plants that we grow, a shift in our agriculture, okay? A moving inland of coastal cities so that they're not, permanently flooded with the ocean. All of these things takes a lot of money and manpower that less developed nations don't have. Less developed nations are focused on feeding their citizens and fighting wars. Okay, they're less focused on, a potential climatic threat. All right, and it's unfortunately something that, unless the world comes together to address climate change, we are going to see a significant amount of loss of life due to the effects of climate change. Okay, so it's something that needs to be considered sooner and not later.